So today, rather than the long rambling presentation I did, we're going to focus just on motors. In fact, one particular type of motor. This is what's called a inductive AC motor. There are many different types of motors. We're not going to, some of you probably are familiar with DC motors, brush DC motors, servo motors. We're not going to talk about those today. We'll have other sessions where we'll talk more. We'll talk about other types of motors. The reason this is probably the most common motor you're going to encounter is typically in things like fans. Yeah. And
what's it called?
Inductive AC. And if you want the real technical term, because of this guy here, which is a capacitor, it's called a permanent split capacitor, PSC. Inductive, because there are other types of inductive motors. All right, so what we're going to be doing is I've got a box with a bunch of different fans and motors, and there's different flavors of these things. That's why there's a bunch of different ones. But most of what we're going to be doing today is how do you examine this thing? First, how do you recognize what you have? Because if you don't know you're dealing with an inductive motor and you think you're dealing with a brush motor, your analysis is not going to make any sense whatsoever. Okay? So it's important to understand that you have an inductive motor. And this guy here is a dead giveaway. Not all motors have this. This is a capacitor. It's what's called a starting capacitor. And not to get into the technical details, but what it does is it creates a asymmetry in the magnetic field in the motor, which then causes the thing to turn.
Turn in a certain direction.
And it turns it in a certain direction, right?
Okay.
If this was not present, the thing would just sit there in equilibrium and not turn. If it turns out, though, if you gave it a spin, chances are it would continue spinning. Okay? But this is just kind of a trick for automatically getting the thing spinning. Okay?
So can you characterize, John, the difference of the key factors that distinguish a brush motor from an inductive AC?
Okay, if you see this, you have an inductive AC. No other motor has this feature.
If you bump on it, like where the cap is.
It's, right, exactly. And these are, I don't think I've ever seen the capacitor inside. It's always on the outside. Okay,
So
and
no brushes on?
there's no brushes. Okay. The other feature, which is harder to see, which I mentioned in the write-up, is that, in fact, we'll take this guy apart and look at the rotor, and the rotor is very distinctive. It's what's called the squirrel cage rotor. It has no wires. It's just a cast aluminum piece, which actually has no electrical connection to this. It's connected only through magnetic fields inside. And the magnetic field is induced, that's why it's called inductive. And
The rotor has no wires.
the rotor has no wires.
But is it called the stator, the one that stays the
The
same?
stator has, you'll have a chance to see this.
Okay.
But you can, I don't know if you can see the copper windings, those are on the stator.
Okay.
The stationary part around the rotor.
Okay.
And we'll take this guy apart and you'll get to see what the rotor looks like.
Okay.
But once again, only an inductive motor has those two features.
Does the rotor have any permanent magnets?
No permanent magnets.
permanent. It's all
That's the really amazing thing. It's kind of a clever trick that Nikola Tesla came up with for that cast aluminum thing is configured in such a way that when you subject it to a magnetic field, it generates its own opposite magnetic field. And
Oh, because it induces
Basically-
a current.
I'm sorry?
It induces
It
a
induces
current.
current, the current induces a magnetic field, but in the reverse direction. And so it's like two south poles
Oh, that's interesting.
push apart. And so the rotor tries to get away and begins to turn.
Okay.
So that's, it's a very
That's
clever,
interesting.
And this is more
Clever.
recent than the brush motor. This was.
yeah, this is completely, right. It turns out that all electric motors work on that principle of the same pole trying to get away,
Right.
and causing
Okay.
them to turn. But then there's different implementations. And so the one we're gonna, because this has a particular wiring that once you recognize this as an AC motor, inductive AC motor, there are certain things you can check. Whereas with a brushed motor, you would check different things.
Yeah.
So the first thing is to say, I know what I have here.
Okay.
Okay. The second we'll kind of get into, well, what is this thing? Where does the electricity go? What is all this stuff about? what's this all about? But also I wanted to kind of talk about, like, in a fix-it clinic, what, what types of things would you check? Okay, and some of the things are in common with all motors, and some things are specific to an inductive AC motor. The first thing is the fuse, and usually the fuse for a fan is in the plug, and a lot of people don't know this. This one doesn't have a fuse in it, but if it has a fuse, it has a little door, and you open the door, and there's a tiny little fuse, a little Christmas light string type fuse, tiny little fuse, usually 10 amps or 12 amps or something. So that's really the first thing you should check, because if the power's not getting in,
I learned that the hard way.
and then you could take the motor apart and study it,
Oh.
dig out the thermal fuse, and it's, and then it turns out it's something silly. Just to kind of get it started at ground zero, there's a neutral prong and a hot prong, and the neutral prong is a fat one, and the hot prong is the skinny one, and also the neutral line is the one with ribs, and the hot one is flat. Okay, so if in fact, it'll be important to know which prong is the neutral one when we start checking the motor. Okay. Okay, so the first thing to check is the fuse present? Is it blown? And you check the fuse with a multimeter.
So if it doesn't have a fuse box in the plug,
Chances are it doesn't have a fuse. It may have a thermal fuse. For example, this has a thermal fuse, no fuse in the plug. So, all right. So the next thing, once again, you don't really need to understand the physics of this, but a lot of fans I have fixed because they've been sitting around for so long that they kind of get stiff, and in fact, do you remember the boot warmer way back? This was one of the Acton fix-it clinics, but it was a woman who was a ski instructor on the show, but brought in her boot warmer. She said they don't work anymore. Okay, and it turns out because they sat all summer in her basement, the
it wouldn't start up.
the bushings kind of got oxidized.
Oh, there was a motor
Okay,
in
and-
there?
Oh yeah, it blows air in. It blows air into your boots.
Oh, it dries
It's a
the
heater.
boots.
It dries-
Yeah, I've
yeah,
seen those, I've seen those,
yeah.
right, okay.
And she thought it was brilliant, but all it took was just turning the shaft of the motor a little bit. And that
Not
was
to
it.
go sideways, but someone once told me that you need to use a special lube for motors, is that true?
Honestly, I don't know the answer to that.
Yeah.
I
was
sometimes use
suspicious when I heard it.
sewing machine oil.
Yeah, right,
That's something that's generally expected, in fine mechanical parts.
right.
I don't think you want to get oil on brushes, but we'll talk about brushes another
right.
time. All right, then the next thing, once you realize the fan turns okay, like this one turns pretty smoothly, okay, a lot of times, the problem's not in the motor, but in the switch. Okay, there's been a lot of switches where I've ended up replacing them because, a lot of times when you turn them, they feel kind of crunchy. That usually means that there's some, so once again, nothing to do with magnetic fields.
So how do you know if something's an induction motor that might actually have that that other piece inside it?
The thermal fuse,
Yeah.
you eventually get to a point where you say, it could be the thermal fuse. And then you take it apart, and the thermal fuse is in the stator, the stationary part on the outside, buried in the windings.
Ooh,
Okay, in fact, I have a fan here where
how
I
do you
replaced
replace it?
with very, very carefully.
Mm.
Wow.
Yeah,
Wow.
but I managed to revive one fan by changing the thermal fuse.
Okay.
So, and soldering a thermal fuse is
That's trouble.
tricky.
Because you blow the fuse.
But they have really long leads, so you just have to do it really fast
Oh, okay.
before the heat propagates to the
Right,
thermal
to the
fuse.
fuse,
Yeah.
yeah.
All right, so, but once again, a lot of, to sort of diagnose these things, a lot of it is incredibly simple stuff. So the switch might be good. If it feels crunchy, you can pop them apart, But usually when you pop them apart, all the pieces just
You
explode,
won't get them back together.
you know?
Yeah.
So it's time to send the Fix-It Clinic customer to, Ace Hardware to get a switch, if they have them. All right, so yeah, actually, so the next thing is if the switch is okay, and say the motor won't run, and also you go through the testing steps, which you will do with your multimeters. And it doesn't check out, like the testing that you do. In fact, I'll kind of explain this. It's remove this statement. Typically, an electric motor inside has a bunch of windings, and that sort of form a kind of a loop. And then you have your switch, which is connected to hot. And your switch, this is maybe just a 2-speed fan. This is high, and this is low. So let's say your switch is currently connected to high. You have current flowing this way, and you have current flowing this way as well. Okay, but maybe we won't worry about the current at the moment, because I'll just. Okay, so each one of these things they're coils, but they also have resistance. Okay, and when your fan, this is not plugged in, when your fan is set to high, you should measure a certain amount of resistance to neutral from hot. See that there's a complete path here. This is a capacitor, so this is open. So you're not going to see this resistance. And this is a gap, so that it doesn't connect to neutral, so you're going to see this. So you'll write down, something like, I don't know, 70 ohms. These are usually pretty small. Okay. Then you'll switch your fan to low. And notice now, say this is maybe an additional 20 ohms. Now you'll measure, when it's on high, you'll measure 70. When you're set it to low, you'll measure 90. Okay? And another thing you can measure is from here to neutral, you should see 0 ohms. It's a direct connection. And if you measure it from hot to the other side of the capacitor now you've got a path that goes this way. And so now you've got two parallel, actually, if you just put your probe here,
Do you typically have access?
you'll see how we do it.
Okay.
Yes, we do. And so, actually, initially, the hot, okay, all you need to do is, okay, this is off,
Resistance, that's when it's
that's on one setting,
the highest,
and just by checking,
more resistance.
okay, the resistance across the terminals here, you will measure that.
So the low should be the higher resistance?
Yes, okay, because when you have less resistance, you have more current,
Okay,
okay? You have less coil involved,
okay.
okay, but more current. And the more current actually
What
is the
that?
more dominant,
Okay.
Stronger fields.
yes, it's a stronger magnetic field. And the other thing, which I don't really want to get into the physics of this, but this involves fewer of these, what are called poles. Because what the motor is going to do is it's going to try to get away from, because the outside thing and the rotor are the same magnetic sense. Say they're both south, so it tries to get away, but then stops at the next one, which is north.
Right.
Okay, so if you only have two, like at the top and the bottom, it's going to keep going until all the way down here. Okay, but if you then say go to add the low, then it's going to only go a fourth of the way. So it's actually going to turn half the speed.
So more poles is more what?
More poles is slower running.
Slower.
Okay.
Yeah, but you guys don't have to worry about that. To diagnose this at a fix-it clinic,
That's
you know,
why the lower speed.
it's just kind of nice to know.
Okay.
Okay. The important thing is, you can do this initial diagnosis without even taking the fan apart. All you need is access to the,
So would the high speed just be two poles? Would
Yeah.
it just go from one to the other?
it's actually, I think it's, no, you're right, it's 2 poles. It's always it's a power of 2. There's 2 poles, 4 poles, and 8 poles.
Oh,
Okay? If you have 3 speeds, you have 8 poles.
cool.
So, but in any case, so if you measure, if you do, let's see, put your switch on high, and you,
I know this. It
Okay.
always, it burns out more easily when it's on the high setting.
well, that, yeah,
I know that.
Right,
because That's
okay,
all my son does,
okay,
is put it on high. And then he leaves the house, comes back, and
Couple weeks
eventually
later.
the fan is blown out.
right. So if you measure, you put it on high, you measure between the prongs of the plug. So you have your, you measure the resistance there with your multimeter,
Yeah.
and you get infinite.
Cool.
That tells you there's something wrong.
Something wrong.
Okay, there's a break.
Mhm.
Okay, and that's possibly where the thermal fuse is.
Okay.
Okay, the thermal fuse actually typically is not there, but it's all the way here on the going back to neutral.
Yeah.
So then you can justify opening the motor and looking for the thermal fuse.
Well, where is the source of heat that this thermal fuse is meant to measure? Is it the bearings, or is it the inductors there, or what is
It's,
it?
in the case of that fan there, it was the bearings.
Okay,
That, the shaft just got really hot,
okay.
and eventually, like, the whole housing's metal, the whole thing is really hot.
So that's what it's trying to protect, is the bearings then, okay.
It's not protecting the bearings, it's protecting your house from
Well,
burning
yeah,
down.
okay, yeah.
But it eventually, they're only like 150 or 147 C,
Okay,
so, which is kind of hot, it's well above boiling water. So then, if you get infinite resistance, that probably means either a wire broke, which is really rare, or the thermal fuse
Yeah.
burned out. And typically, see, where your electrical fuse is, which makes more sense, it's here, let's say this hot and this is neutral. Your fuse is here, so nothing even gets in when the electrical fuse is burned out. And the thermal fuse, it turns out that's like the best place to put it in terms of design. Because no matter what's causing the heat, just kind of cuts the neutral. And now you no longer have, let's see, you have a gap here. And no matter where you have the switch, it's not getting back to neutral air. So, all right,
Can I ask a quick question?
sure.
So in that case, we're looking for either resistance or no resistance.
Exactly.
But we don't know what the resistance is.
So I'm gonna have you and Rob,
We don't know what the resistance is supposed to be.
no, you don't know what it's supposed to be?
Right.
It's kind of a good idea, well, actually, there's a pattern, which I'll talk about in a second, but just go ahead and set, okay, currently I have this off, let's see here. I think I have this off, or on high speed, or it's one or the other, and measure the resistance between the 2 prongs and see. In fact, for each of the settings, we'll in fact write them down. You might see a pattern. Yeah, that's a really high resistance. So that's when it's off. Now, put it on a different speed. You'll all have a chance to play with this.
Yeah, it's different now, it's 74.
Okay, so 74. Okay. We're gonna call the first one infinite. What's the next one?
88.
That's a battery and some magnets.
Okay.
It's got the
Is there another setting?
safety pins.
One under 2.
Okay.
It's all the fun stuff.
All right. So this is off. So that's when your switch isn't connected to anything. This is high, medium, and low. And notice that the difference between this and this is what, about 14 ohms? And the difference between here and here is also 14 ohms. So these two, well, actually I only drew for 2 speeds, but I've added a third thing. So it turns out the first resistance to neutral is fairly high, and then each one has kind of a small resistance. So this is a healthy, a healthy motor. If you don't see a pattern like that, for example, if you have like a big one and then a small one and then another really big one, there might be something wrong. But or if you get another infinite, that means it's a break. So
Is there a reason why so often you see switches that go 0, 3, 2, 1 instead of 0, 1, 2, 3?
It's
Yep.
not intuitive. Yeah.
they're almost all 3 to 1
Huh.
Yeah, exactly.
because to get the spinning started, you want the strongest magnetic field.
First to go.
So you have to go through
You
it.
have to go through the fast
Right.
one, through the hard, through the strong field to get it turning.
Good design.
Yeah, so. All right, and I didn't mean to take up so much time here, but I guess it might be good. All right, so if if all of these, for example, are infinite, that probably means your thermal fuse is blown. So I don't really want to take that fan apart again to look at the thermal fuse, but I do have. All right, so this is not exactly from a motor. It's actually a transformer, but it's got the same concept. It's got a thermal fuse, and I'll start this in with John. And I dug it out here, and I broke some wires, so this coil is probably not recoverable. But that's what the thermal fuse will look like.
Oh, it's embedded in.
It's embedded in there, and it's covered by that tape. So, and if you kind of undo it enough, you'll see that it has long leads and is connected to some fine wires that are in the windings. All right.
Pretty small.
That's to prevent a fire.
All right. So then there's actually before you actually start digging for the thermal fuse, I should have put these in more order.
Wow.
Line.
That's the fuse
Yours
right
must be
there.
more sensitive.
Right.
than mine.
Yeah, I guess so, yeah.
Mechanisms are off.
That's interesting. I never knew such a thing.
Yours probably got more decimal points than mine does.
All righty. Okay. Another thing that can look like a blown thermal fuse is some fans have a thermostat.
Hmm.
Okay, and sometimes that thermostat gets stuck open.
Hmm.
So it's in fact, usually,
It would have it in without speeds? You typically not have a speed?
it's just a temperature dependent switch.
Oh, okay.
Okay. And if it gets stuck open, it can look like your thermal fuse,
Okay.
because when you check the resistance between line and neutral, you'll get all infinites. You might say, oh, it might be a thermal fuse. But oftentimes it's something simpler. The thermostat is stuck. So the first thing
Interesting.
you should, and thermostats are pretty obvious because the fan, in fact, this fan has a thermostat, it's got 2 switches.
What's the thinking behind the thermostat on a fan?
It's when, I think they're kind of a silly feature, to be honest, for a fan. But if you have them in a window
Yeah.
at night, and it gets too cold,
Oh,
you want the fan to stop.
That's a good idea.
Okay,
Okay.
okay,
Wow.
okay,
In fact, I've got 2 fans like that,
okay.
and, they're kind of pretend air conditioners, maybe
Yeah.
in a reverse sense.
Yeah.
Yeah.
I don't know. All right, then there's 2 really rare things. Is broken wires, except, I broke those wires playing around with it. They typically don't break spontaneously, unless they're really badly manufactured. But it could be, like the thermostat is okay, you check the fuse looks okay, then you probably might have broken wires somewhere. At which point, the motor is probably toast, unless was you there saying that you watched somebody rebuild a motor?
Yeah, I've seen that on YouTube.
Yeah, where they actually take all the wires out
Right, yeah.
and put in whole fresh wires, and they get it to run. It's really amazing.
It is, to my mind.
And the last thing is the capacitor may have failed. To be fair, I have miswired ceiling fans and turn the switch on and the capacitor makes this hissing noise and there's smoke. So, if somehow, it's possible that the capacitor is bad, but typically if your fan isn't working, it's probably not the capacitor, it's one of the earlier things. Could be that it just sat around for too long, or you didn't check the fuse in the plug, so. In any case, and then one last thing is, if your fan, once again the fan I have here, which you guys will have a chance to look at, instead of, this is a mechanical switch, and I honestly don't know why companies decided to start using digital switches, aside from, oh, you can put capacitor touch buttons on the fan instead of having, a mechanical switch. But then you introduce all this electronics. And with the electronics, you no longer can do this simple test.
No one knows how to do analog anymore.
That could be the whole point.
Well, yeah, so you actually have to take the cover off and get to the leads going to the motor to do this checking. It's significantly more complicated. We're probably not gonna do that. I won't actually have you guys open this fan and see the digital, where the digital stuff is and what you would need to check, but I don't really wanna take the time to, have you guys kind of try to figure out what all these wires are. It's not as simple as just checking the prongs on the plug.
Just gonna ask, so this testing that you're teaching us, this would only work with multi-speed? If it was just an on-off?
No, well, with on-off, you're only gonna have these two guys, and so you're gonna have either off or on.
So the same test would show infinite and then some
It'll show infinite, and then it'll show you some resistance.
something. Yeah.
Right. Right? So, so that's about, all I want to kind of present right now.
Good.
And instead have you guys play around with these things. So, I've got a number of fans, so you might want to work maybe in pairs, it's kind of easier. And, oh, actually, one last thing. Okay, so this is a different flavor of inductive AC motor. This is still an inductive AC motor, but it doesn't have a capacitor. Actually, never mind. No, I'm sorry. This is the switch. Yeah, I definitely know this. Should not have a capacitor. But it has another clever mechanism for getting this thing started. And it's these fat copper wires. Okay, and this approach is called called the shaded pole. So this is, I had some peanuts before I came here, and I didn't take all the little flaky stuff off of them. But this is an AC inductive motor, an inductive AC motor. So if you see these fat copper things, just like the capacitor, what you have is an inductive motor. So that works. And the rotor is once again a squirrel cage thing, and the rotor actually is not fed any electricity. It's just a clever magnetic trick to make it turn. So
Is one of those older than the other, the capacitor or the
I don't know.
shaded pole?
I don't know, both, actually this technology has been around for
100 years.
100 years, yeah. I'm not sure which one was discovered first. I do know that this is for lighter duty. So, for little fan blades, whereas that typically has a bigger fan blade and draws more air. So it's, that's why they chose that versus this. Okay, so,
Question?
yes.
For inductive versus brush motors, are certain appliances or the size of the appliance, is that more likely to determine which type of motor they were going to have, or?
Yeah.
So it must be qualities of one versus another.
Yeah. Typically, inductive motors are things for fans that don't require a lot of torque.
Okay,
Okay. Brushed things are more for power tools,
okay,
where you need a healthy amount of torque.
okay.
All right, so this, in fact, maybe we just move things in the same direction. But go through that same exercise of checking the resistances. This switch
Okay, is that open?
Seems like it.
Okay,
That's two
and we'll go
speeds.
to the first item. That's number 3 maybe.
No, it's
Resistance.
snap.
Stephanie?
It's just like,
Okay,
If it were.
can we get the next
oh,
one?
if it were,
Yeah.
it would,
Okay, and then the next one?
you'd need it'd be kind of a totally different thing.
Okay.
Yeah.
This is.
This is just like saying, am I connected to H or am I connected to L?
Gotcha.
It's nice and smooth. Okay, you can see.
And you should
the,
find that this
you can
is
see 8
similar.
poles there. And the 8 coils.
All right,
Oh, is that the balls,
Switch
what they call
position.
Well, he
balls?
said 2, 4, and 8 on 3 seconds. And you can see that's got 8.
Right.
things. Maybe what.
All right, you can get his-
See,
Let's see. Oh, you know what? I'm gonna have you guys start with this thing here. All right, so this one here, probably is not gonna run right off the bat. You might want to try plugging it in, see if it'll run.
Okay.
And then go through like the different,
Are you quizzing us with that van?
well, come on, it wouldn't be 60 days if it happened here. What fun would it be?
There you go.
Ever had it fool you where it's actually making your fingers?
Yes. What fun would it be if everything just worked?
Let's see. You got that? Okay.
Sounds like it might have been you.
All right, so
You've been.
Yeah, we
Oh, you just
we
play
tested
around?
that one out.
okay, so you saw the resistances. huh?
Yeah.
Yes,
Okay.
yeah.
We-
You had a question of how do you, okay, so
Stands for?
for you guys, okay,
Yeah.
remember you said, well, how do you get to the capacitor? Okay, because there's no terminal for the capacitor, I'll show you how you do it. Which is,
This is capacity.
you guys can do this because it's my motor, but if you're doing this for somebody's, fan that you're fixing,
45.
you probably actually want to cut the wires
I guess it's only.
and then be prepared to reassemble them either by soldering and putting heat shrink or, wire nuts or something like that. All right. So you guys may find it hard to believe this is how you do it. Okay, so we're gonna figure out which of these wires that goes to the capacitor goes directly to neutral,
Yeah, I was measuring myself.
okay? And the way we're gonna do this is with these needle probes.
Oh, I just bought them.
Okay.
Things.
And, see, oh, you figured it out?
I didn't
How's
fix
that?
it.
Oh, really? It's like, it wasn't
We
working.
fixed
The
it!
thermostat has a setting
Oh,
below
okay.
it won't work. If you go all the way
Right.
counterclockwise, it won't work.
Yeah, actually,
So go counter.
I think it's no matter what temperature now, no matter where it is,
Yeah, no,
did it stop? Yeah. I fished this out of, by the way, out of the Sudbury recycling. Somebody threw this fan into the metal bin. See, it's all made of metal.
Yeah, right, total metal comment.
So, okay, so I'm gonna have you guys do this, just don't poke the table.
You're gonna poke it in, that's all.
Okay, so try the one, okay. Well, you know what, we have at least a piece of paper.
These conductive.
Is there?
So it's maybe it's not
I don't
that
have any probes like that, that's interesting. I've seen a
Oh,
needle
yeah.
bed for
Well, it's a sharper
telephone,
now.
for telephone work, but
Okay, so I'm gonna stick it in there and take this probe and put it on the,
Charge.
one of the.
on the neutral.
Neutral, okay, so.
And so do we see a resistance? We don't.
No,
Okay, so let me now try the other one.
In recycling, and one of the ways to separate aluminum cans is by.
So one side should go to the neutral.
One side should go to neutral.
Inductive current that repels compels.
Hold on.
Oh,
So you got it.
Got something.
So the short guy goes to neutral, because you can't tell, because they both go into the motor.
Sure.
Wiring
Okay.
that
So now, we know this guy here
when it gets to a certain.
is over here.
Pushes.
Right.
So now we can go from hot to the other one, to the other side, okay? And see if there's continuity, or resistance,
Okay.
all right? So why don't you try that? So this is the long one.
Is it gonna be on this side? Is that what it was?
Yep. I'm trying to use a hole I've already made if,
I could if I could find, if I could see
That's
it,
okay.
but the problem is I
Yeah.
have no clue.
Yeah.
Except
Let me
to
ask you a dumb question.
Sure.
feel for it.
It sounds like you're trying to measure current, but it's not plugged in.
what was that?
You're measuring.
Try that.
No.
What do you got? Oh, here we go.
Got something, okay.
Yeah, we got 6
Heavy
ohms.
jacket.
60.
Oh, 60, okay, yeah, 59 ohms.
Oh,
Sorry.
Okay.
No,
Yeah,
no, no, okay, that's,
Okay.
Your chair here.
Yeah, so that's through that other coil, right?
that sounded like there was a sonic boom or
Yeah.
something.
Oh, I think my chair tipped over.
So, okay, we're gonna use the med school paradigm here. So, I want you guys
Yeah,
to
what's your opinion
explain
on, you
to
said,
these two guys what we just did there and why. You know, why you saw what you saw.
okay, yeah.